Effects of faults. So we know that there are different faults occurring in power system networks. We have seen their classification and we know the characteristics of these faults also. So now we have to see what are the different effects of these faults on our power system network. So we have already studied the severity as well as relative frequency of occurrence of these faults. So there we have seen that the short circuit faults are the most commonly occurring faults in power system network. So the short circuit faults are the most frequent ones, and here we are going to consider the effect of the short circuit faults. Even though it is generally written as effect of faults, we are going to consider the effect of short circuit faults, which are the most commonly occurring faults in power system network. So the first point is that the heavy short circuit current may cause damage to the system due to overheating and high mechanical forces set up due to heavy currents. So we know the feature of short circuits, the characteristics of short circuit. A short circuit is a least resistance path, provides a least resistance path. So it will be associated with very high currents. And this high currents may damage the system due to overheating. So when a very high quantity of current is flowing through a particular system component, it will lead to overheating of that component. And also these heavy currents will lead to the setting up of high mechanical forces, and it will eventually lead to the damage of the various power system components. So the heavy currents associated with short circuits damages the system components due to overheating and high mechanical forces. Second point is that arcs associated with short circuits may cause fire hazards. So when there is a short circuit at a particular point, there will be arcs at that particular point, and that this arc may sometimes lead to fire. So it can lead to fire hazards. Then, so we know that short circuits are characterized by increased current and reduced voltage. So voltage across a short circuit will be very low. So short circuit will lead to reduction in system voltage. So this reduction in system voltage will lead to loss of individual loads. If the voltage of our power system network falls, it will fail to supply the consumer loads. So it will lead to reduction in supply voltage, will lead to loss of individual loads. Now the third point, short circuits may cause the unbalancing of supply voltages and currents. So we know that there are short circuits which occur in any one of the phases, uh, occur between any one of the phases and the ground, between two phases, between two of the phases and ground. So there are unsymmetrical short circuit faults, single line to ground, double line to ground, etc. So if such faults occurs, it will lead to unbalancing of the system. So system voltage and currents will become unbalanced, and this will lead to heating of rotating machines. If rotating machines are given, like generators and motors are given with an unbalanced supply, it will lead to heating of the rotating machines. So it will finally lead to the burning of the machine winding, etc. And next point is that alternators in different power stations may lose synchronism due to reduction in supply voltage. So in a particular power system network, there can be a number of generators, number of alternators for generation of power. And all these alternators will be synchronized with each other and with the power system network. So we have studied certain conditions for synchronizing alternators, for parallel operation of alternators. So one of them, so we know the various conditions, that their frequencies should be equal, their phase sequence should be equal, and one of the main point is that their terminal voltages should be equal. So we are synchronizing alternators to a grid after ensuring that the terminal voltage of the alternator is equal to that of the grid voltage. So if there is a reduction in system voltage due to the occurrence of short circuit fault, that equality in terminal voltage and the system voltage is lost. So as a result of this, the alternators will lose synchronism, and this results in loss of system stability. If alternators go out of synchronism, it will lead to the loss of stability. The system will become unstable. And all these problems mentioned above will lead to interruption of supply to the consumers and thereby causing a loss of revenue. So these are the various effects of short circuit faults on power system networks.